Hey guys, this is Ron. So this is a video response to some questions I received on my email video lab. So in December-ish time frame, I created a couple videos explaining how to connect a remote site into your corporate network so that you could access the email server that's there. So in the first video, we did static NAT. That worked pretty good but wasn't secure. Then we implemented GRE in the second video and then applied IPsec to that GRE tunnel in the third video. So in this video, I'm going to kind of cover a couple questions I had, namely, how do you connect more than one site, and secondly, what happens when one of those sites is sitting behind a modem that signs out DHCP addresses and then also applies NAT. How does that going to affect your configuration? So I came up with a solution. It took me a little while on GNS3 here, but I'll kind of explain to you how I came to that. I will give you a caveat that I'm a CCNA certified, not CCNP yet, still working on it, and definitely obviously not CCIE. So these advanced topics are somewhat beyond me, so my explanations of them might be slightly limited, but I will try to explain what I can. Anyway, so let's kind of jump into it. The first kind of bit that we're going to run into is we have this corporate router here. It has a static IP. We have a remote 3 here. It has a static IP, and then we have remote 1 here. Remote 1 gets a DHCP address assigned to it, and then the modem there is running NAT. So we're going to kind of run into some issues. The scenario here with these two routers, no issue. We could build tunnels just like we did in the last video, and it wouldn't be that big of a deal. But to support this guy, we're going to have to change quite a few things up. So let's kind of jump into it. Bring up a website here. So this is trainsignal.com. They've got a couple of graphs here, or pictures, that really break it down pretty easily. This is the normal scenario that we had before, where everybody has a static IP out here. They're going to build a tunnel back to the corporate router, so the corporate router ends up having a tunnel for every remote that it supports. Now this might be hard to scale, that you end up with tunnel after tunnel after tunnel after tunnel for every single remote site, and plus you have to have a tunnel destination for every one of them. So again, these have to have static IPs out here, and then again these just point in the opposite direction, point back to the corporate router, or this hub. Problem is, I can't guarantee this IP out here from one of my remote sites, so I won't have anything to put in for tunnel destination, so I'm sunk. Moving on, we move into dynamic MGRE using static NHRP. So this is running dynamic at the hub site. So what we've done is we've combined all of the tunnels that we had previously into this singular tunnel. We're using multicasts to dynamically build tunnels or connections out to each of the remote sites. And what we do is we're saying IP NHRP, which is the next hop routing protocol. We're going to map our multicasts. As we send them out, we're going to send them to these physical interfaces. 172.16.1.2, it lines up with the physical interface on this remote, the fast ether address, right? And then up here, we're going to map to get to these internal IPs, the 192.168.1.2, which is the tunnel. Correction. Yeah, I just read it wrong. 192.168.1.2, which is the tunnel itself. We're going to use that physical interface to get to it, 1.2, which is right here. Okay. So to get to the internal or this logical address, use the physical address. Okay. And then we have to do some crazy stuff with EIGRP, being that we're using the same tunnel for every one of these connections. If an advertisement comes from this remote, Split Horizon says, well, I can't send the same advertisement back out the same interface it was received on, so then none of the rest of the remotes learn about it. So we turn Split Horizon off. Now again, this setup isn't going to work for me because I'm still referencing those physical interfaces from the corporate router or from this hub, and I'm not going to know that address. So moving on, Now we're going to do dynamic on the hub side and dynamic NHRP on the remote side. So what we see here is IP NHRP map multicast. Now we're dynamic, whereas before we had the actual IP address of our remote in there. So now we're in dynamic here, and from the remote side we're mapping back. Okay, prior to that the setup on the remote was pretty much exactly the same, source and destination. Here we're actually mapping again, so we're saying, hey, you're going to send your multicast to 172.16.1.1, which is the physical interface, and then we're going to say to get to that logical address, use the physical address. So logical 1.1, physical 16.1.1 right here. Okay. There's also this next hop, I think it's next hop switch or something like that. Again, my understanding of some of these concepts is a little limited. I got to do some more research, but basically 192.168.1.1, we're pointing back to that logical interface. Okay. And then there's some network IDs and this and that. I just copied pretty much what they had there. So this is the setup we're going to use because we don't have to reference physical interfaces out here from the corporate router. Okay, so that's what I'm going to do. That'll build our GRE tunnels all the way back to this corporate router. Now, I won't be using EIGRP. I'll be using Ospf. So if we jump over here on the Cisco's website, I found a couple different setups. So basically the command we'll be using is IP Ospf network point to multipoint. We'll be doing this on the tunnel itself. And the reason we do this is because Ospf is going to think it's on a point-to-point link, so it's going to say, hey, I can only establish one neighbor relationship on this one interface, so it's not going to work. Prior to me putting that command in there, when I try to bring up my second remote, the network would fall apart. It was just a disaster. But you put this point-to-multipoint in there, and Ospf's like, oh, really? Right on. And it builds multiple connections. Okay, so once we've done that, Ospf should come up, and then we'll come out here. We'll build our crypto. So this is firewall.cx. He's got a bunch of really great explanations about how to set up IPsec. I use the same setup. It should look familiar from the email server video. We'll make some slight changes to this, namely on this crypto map. We won't be doing the crypto map. Instead, got this other website here, again, cisco.com. We'll be using a Ipsec Profile. Okay. Now, what the difference is between the profiles and the crypto maps, I'll be honest, I don't know. But I know that using the profile worked for me, and it's what I'm going with for this video. Again, I've got to go back and do some more research on why that is. And then lastly, when we get to that NAT interface, what we'll find is everything's going to work up to the point of applying IPsec, and then it's going to fall apart. And the reason is NAT is going to really cause some problems with establishing that security association. That ISACAMP is really going to struggle. Okay, but there's a couple of things that you can kind of enable. One is NAT-T, in which I'll show you, that's going to allow us to get through that NAT interface and kind of build our association. So I don't know if that's the best way to do it, but again, that's how I've found to get it to work. Okay, so if we minimize this, this is our network that we will be configuring. So let's jump into the configuration. Okay, so first we're going to configure our corporate router. We'll move to remote 3 and then remote 1 for our GRE tunnels. So what I'm going to do is I'm just going to kind of copy and paste in there, and we'll talk about what I've put in there. If I have to type it out, it'll take too long, and I'll probably type something wrong. So anyway, so we'll do show IP route. We've got here's 2 connected interfaces, and then a static route that just points to the ISP router. So nothing tricky in here. We configured this interface, configured this, or configured the 2.2 interface, which is a fast ether, and we configured our interface going down to the computer. So, and we're just sending it up to the ISP. So let's make sure we have connectivity. We'll do ping 2.2.2.1 to ping 2.2.2.1. That should work, and in the meantime, let me jump over to my cheat sheet and we'll create the tunnel interface. Let me copy and we'll paste in there. So what we've done is we created an IP address. So we called this 10.0.0.1. I gave it a 248 subnet mask, and this allows me to have a small network there. So we want to make sure all of our tunnel interfaces are obviously in the same network. You see IP NHRP multicast dynamic, just like the previous web page showed. I probably don't need this. I could probably try it later without it. This is our OSPF statement telling it this is a multi-point link. Tunnel source is fast ether 00. Tunnel mode is GRE multi-point. Okay, so nothing crazy in there. Let me go ahead and paste in my OSPF configuration. Copy and paste. So what we have here is router OSPF 1, router ID. I made the router ID match the tunnel interface. We have passive interface default. So I'm not going to participate in OSPF on any interface except for the no passive interface tunnel 0. Then I have my 10 network and my 172 network. So again, nothing tricky there. Let's go ahead and minimize that. We'll bring up remote 3. Do show IP route. So again, we have two of our interfaces, fast ether 00 and fast ether 01. We have a static route to send everything to 3.3.3.1, which is the ISP for this remote. Okay, so do ping 3.3.3.1. We should be good to go. All right. Oops, a little hiccup with GNS, but good to go. All right, so what I'm going to do is I'll bring up my cheat sheet here to the side for what do we got? Remote 3. No. Yeah, we got remote 3 right here. So let me copy the interface out and Control C. And what just happened? Really? You gonna play me like that? All right, come on. How about Control C and paste? There we go. All right, so created the interface. Again, IP address is in the same subnetwork as the tunnel in the corporate router. Here our multicast map points to that 2.2.2.2 interface, which is the fast ether address right there on the corporate router. So let me bring that back up. We're mapping that internal tunnel IP on the corporate router to its outside interface. And we have this NHS pointing towards the inside interface, that loopback, or not loopback, the tunnel interface, right? And our tunnel destination, 2.2.2.2. Okay? That's pretty much it right there. Let me see here. Let's go ahead and grab in OSPF. Copied and pasted. Oops, apparently I didn't paste everything. Area 0, there you go. And we've built a neighbor relationship. So that was quick. So if we do a do show IP route, we'll notice that we're getting O's. So that's good. Let's go ahead and do ping 172.16. I think it's 0.1 is that. There we go. So that's the fast ether 01 interface off of the corporate router. Okay, so that's good to go. We'll go ahead and minimize that, and now we'll configure up remote 1. Okay, before we configure up remote 1, let's go ahead and we'll start capturing on the interface here for the corporate router, and this will enable us to kind of see traffic as it's coming in. So what we'll see here we see some hello packets going out and what have it. Notice we're running a GRE. So what you see is it's coming from source 2.2.2, destined for 3.3.3, which is our remote 3. Inside of that GRE is source destination 10.0.0.1, which is the tunnel interface, and destination is a multicast for Ospf. Okay? So nothing too crazy. Let's go ahead and open up remote 1. What we'll see here is if we do a show IP interface brief, we have a private IP, okay? Instead of that public IP that everybody else is kind of using, we have a private IP. But if we do a ping 2.2.2.2, we'll make sure we've got connectivity all the way back. There. So we've got connectivity all the way to it. Let's bring up Wireshark and see what it saw. So we're definitely applying NAT, because you see what's coming in is 1.1.1.1, but we were using the 192s. So NAT's definitely getting applied. But we'll see if we can build an MGRE tunnel with it anyway. So let me bring up my cheat sheet here to the left. Let's see. There we go. Let me grab my tunnel, and we'll do a copy. Oops. Clicked on something there. Remote 1. Big T. Paste it in. We now have our tunnel. Nothing crazy here. We got our IP address. So now we're 10.0.0.2, and we're pointing towards that setup on the corporate router. So nothing different there. We did the same exact thing on the other remote. We'll paste in our OSPF statements. Alright, so OSPF is now in there. We are no passive on the tunnel as well. So let's bring up Wireshark. Oh, there we go. So it built the relationship. So now if we do a show IP OSPF, let's see there. Wrong command. We'll just do a show IP route. So now we're seeing all the O's from everybody else. If we do a trace, we'll go to 172.16.3.1. So this is on remote 3. So notice we went to the corporate router tunnel, and then we went to the tunnel interface of remote 3, and then we're there. So everything goes back to the corporate router and then goes out to the respective remote site. Okay? So now at this point, we're going to go ahead and start our crypto configuration. Alright, so let me bring my corporate router back up. I have copied out my crypto statements. Okay, so here's what we've got. We've created a IceCamp policy. We're using the AES MD5, pre-share, Diffie-Hellman group 2. The only real difference in this command is kind of truncated. It's actually IPsec or crypto IPsec, or nope, crypto IceCamp key. This is the key that I'm using, my secret key, address. Typically you have a peer right here. I'm using all zeros because, again, I don't know necessarily who my distant end or what IP the distant end is going to come up on, so I just used quad zeros. I don't know if that's the best option there, but it's worked for me. Okay, down here I've created a transform set, and again, if you go on that some of the websites I mentioned earlier, they do a better explanation. My email lab, I talk a little bit more about what each of these things do. But basically, we created a transform set that uses AES and MD5 as the encapsulating security payload. You come down here, and I'm creating my profile. So whereas we created a crypto map before, now we're creating a profile that just ties that transform set into it. Okay? So again, not sure the difference between the two, but this seems to work for me. So if we do interface T0, so we're going to go to the tunnel, and I'm going to go ahead and copy it out, and we'll paste it into the tunnel. Oops, I highlighted it over there. Control C. Let's back up. Alright, so tunnel, protection, Ipsec, profile, and then the one that we created, this Ipsec prof. Go ahead and apply that. What we should start seeing is ISACAMP turns on, and now it's going to start complaining that the packets that it's getting in aren't set up for Ipsec. Okay, and eventually we'll lose neighbor relationships with our neighbors. So we minimize that. We'll bring up the remote 3. I'll go ahead and bring up my cheat sheet over here. I'll go ahead and copy the crypto configuration off of it, and we'll take a look at it. Alright, same basic setup. We're creating an ISACAMP policy, AES MD5 pre-shared key. The only difference here is our peer is the 2.2.2.2, which is the corporate router's FA00 interface, and then everything else is the same. Okay, let me go ahead and copy out that, do interface T0, and we'll apply our profile to the interface. So now we've turned ISACAMP on. If we bring up Wireshark, what we're starting to see is these ISACAMPs are exchanging. So we're starting to build our security association, and now we've got ESPs. Okay, so we should have built a neighbor relationship, and now as they talk, each of the packets is encrypted. Okay, let's see, still hasn't built. Let me give it a second. Do show IP OSPF. Maybe it's just that it built before the neighbor relationship actually failed. So let's try it out. We'll do ping 172.16.0.1, and we ping through. So, and if we go back to Wireshark, we won't see those necessarily those pings. What we'll see, if I go all the way to the bottom, is all of these ESPs, encapsulating security payload, I believe. So those should be the ICMPs that I sent, and it should be, like I said, encrypted. But here, notice we're getting these destination unreachables from 1.1.1.1. So we're starting to see some issues with NAT already, and we haven't even applied IPsec to it. So let's minimize this, and we'll jump into remote 1. Alright, so let's jump into remote 1. Alright, bring it up. Go ahead and bring up remote 1 on the side here. Let's see. I'll grab the crypto statements. Control C. Oh, you gotta be kidding me. There we go. So here we go. We've got crypto ISACAMP, same as before. Crypto ISACAMP key, same as before. Transform set, same as before. We built the profile. Except apparently I didn't highlight the whole thing. Seconds, 900. Okay. So let's see. Set. Arm set TS. I just didn't copy the whole thing. So exact same setup as what we did on remote 3, but watch what happens when I apply it on the tunnel. So interface T0, paste it in, put it in there. ISACAMP comes up, but all of a sudden we start getting issues right away. Receive registration reply packet with error, unique address registration already. So we're starting to see some issues. And if I bring up packet tracer, or not packet tracer, but Wireshark, it looks like Wireshark crashed, so we'll quit without saving. I'm going to clear stopped captures. How about we stop all captures? Clear stopped captures. start capturing. What we should start seeing, if I drag it over here, is we're trying to build ISACamp, right? So we see these ISACamps 2.2.2.2 to 1.1.1.1, 1.1.1 to 2.2.2, but we're not getting a lot of traffic here. Something isn't quite right. If we watch long enough, here's what we're going to start seeing is destination unreachables. And we come down here and look, and we're talking about port 500 here. Port 500 is where we're going to be building ISACamp, security associations. So if we can't get to port 500, we're not going to be able to build that association. So I'll minimize that. Let me bring back, let's see, what do we got here? Let's bring remote 1 back up. Exit out of the tunnel. And I think it's crypto, IPsec. What do we got here? We've got NAT transparency. There we go. Question mark, UDP encapsulation. Okay? So we're going to take that same command and we're going to apply it to each of our other routers. Alright, so let me bring up the corporate router. Apply that as well. And then I've also found that if I'm not doing that on the other remote, even though the other remote isn't sitting behind there, if I don't apply it there, it doesn't work either. So I've now applied it to my 3 interfaces. Now whether that's the correct way to do it, again, I'm CCNA, it's a little bit limited, but I know that if I don't have it there, the way that I have things set up right now, it does not work. So if I do show IP OSPF neighbor, eventually I think everything tends to crash. But let me try it once. So ping 172.16.1.1 or 0.1. Do ping 172.16.0.1. Okay, that one's working. I've had it before where it wouldn't build at all until I reset all the tunnels. So let me see, ping 172.16. This is remote 1, so 1.1. How about I actually do it 1.1. So it's not reachable. It doesn't know how to get there because we haven't built a neighbor relationship yet. So do show IP OSP. Hey, there it finally built. Or no, it finally crashed. So we lost our neighbor relationship with 10.0.0.2, which was oh, that's never mind. Let me do show IP OSPF neighbor. So I've still got it with 3, but not with 1. So let me go ahead and interface T0, do a shut there. I'm going to come over here to remote 1, interface T0, I'm going to shut, so that should bring ISACamp off, no shut, no shut. And let's see what happens. We'll give it a second. So the interfaces have come up. Source address 3.3.3 is still having issues. And that's my other remote. Let's give it a second. I might need to reset that one too. Let me come up to remote 3. Interface T0. Shut. ISACamp comes down, tunnel comes down. Do a no shut. ISACamp on. Tunnel up. Give it a second here. Alright, so I built a neighbor relationship in the background with 10.0.0.2. And I've now built one with 10.0.0.3, So from the corporate router, if I do show IP OSPF neighbor, I am neighbors with both 3 and 2. So if I do a ping 172.16.1.1, how about a do ping? How many times am I going to do that wrong? I don't know. 172.16.1.1. Alright, so that's remote 1. How about 3.1? And that one works too. So now we are up on both of them. If you notice, they're all ESP packets from here on out pretty much. So the communications that we have between all of our remotes and the hub are pretty much all going to be encrypted. So that's pretty much it. So again, it's a little kind of crazy finally getting them up like that. I've had to do some no shuts on the tunnels when it's switching over to that NAT-T. But once I do it, it seems pretty stable. So if you are smarter than me, which you probably are, go ahead and shoot me some comments. Maybe you know of a better way to do it. But this is the first time I've implemented it in this way. So again, it's a learning for me. So hope you got something out of the lab, and appreciate you watching.